So the first part wants us to go from here to here, and I think it makes sense to start with the top equation and try and simplify it as much as possible. So we've got just causes in the bottom equation, whereas we've got sine and tan in the left-hand side of the first equation. So I think the first thing to do is get rid of the tan, because there's not that much you can just do with sine x by itself. But I can use the fact that tan x is sine x divided by cos x. Okay, and now I can sort of see that, how am I going to get my 5 cos x? Well, if I multiply through by cos x, that's going to sort it out. So I'm going to get 2 sine squared x equals cos squared x plus 5 cos x. And I've made this a bit simpler. I've not got to where I need to at the moment. In my final answer, I've got cos squared, whereas now I've got sine squared. So I need to replace this by 1 minus cos squared x, because I've used the fact that sine squared plus cos squared is identical for any x to 1. So I can just rearrange to get that sine squared is 1 minus cos squared. So that's going to give me 2 minus 2 cos squared x equals cos squared x plus 5 cos x. And I'm nearly there. So that should have been equals. I can see I'm going to add the 2 cos squared to both sides. I'm going to minus a 2, and then I'm going to get the answer. 3 cos squared x plus 5 cos x minus 2 equals 0, and we've shown it. Hence, solve this equation here. See, this equation looks absolutely horrendous, but if we compare it with the top equation, all I've got is I've replaced all my x's by 2 theta. Yeah, all I have to do is replace this, and then I've got exactly, sorry, that one as well, exactly the same thing. What does that mean? That means I can take this equation that I showed the first one was equivalent to, and then just replace all my x's by 2 theta as well. So that was part 1. Okay, I'm just going to say that the equation becomes 3 cos squared 2 theta plus 5 cos 2 theta minus 2 equals 0. And we've got a quadratic in cos. We could, cos 2 theta rather, we could do a substitution. You could let u equal cos 2 theta. I think I'm just going to jump straight into it here. I'm just going to write my factorized form in terms of cos theta. So if this is going to factorize, always a good method to just try and factorize it first, then it must be that I've got 3 cos theta, cos 2 theta, sorry, and cos 2 theta. So I'm not actually doing this substitution. Yeah, that's the only way I'm going to get 3 cos squared 2 theta, because 3 is prime. And then I've got a minus 2. So how am I going to deal with that? Well, I need to get a plus 5. So if I put plus 2 here, then I'm going to get plus 6 cos 2 theta. And then the minus here will make it all work. And then this is still equal to 0. So I factorized it. So cos 2 theta is going to equal a third by setting this left-hand bracket equal to 0, or minus 2. Now this is nice, I can just immediately reject this because cos varies between minus 1 and 1, so this minus 2 is not possible. And what's it asked me to do? It's asked me to find theta between 0 and 180. Sorry, theta. So I'm solving for 2 theta, so it's going to be between 0 and 360. Okay, if I want to find 2 theta, then it's going to be inverse cos of a third. And and that's going to give me a solution here, and then I am going to get another solution here. So let's work this out. Inverse cos of a third is 70.528. So that's this one here. Let's say this was x. Then how am I going to get this one? Well, because of the symmetry of the curve, this is 360, and so this is 360 minus x, and so my second solution is 360 minus 70.52. Actually, I'm just going to add another decimal place in there. Therefore, theta. Okay, so I've got all my values because there's not going to be any more because I'd need to add 360 on. There's no negative ones. I'm nearly done. Just need to write down the answers now by dividing by 2. Theta is going to be 35.3 degrees or 144.7. They did ask for answers to one decimal place. So, quite a bit to do there, but being asked to do number 2 right from the off, it looks really horrible, but they have helped us out with part 1. There we go, 5 marks.